So the last drying event that we're going to look at is a 4,100 bushel of malt barley. This has a 5-horse turbo inline centrifugal fan, so it's slightly premium fan. We're moving 5,300 CFM of air, so 1.3 CFM per bushel, slightly higher airflow rates per bushel. The drying conditions were good, not as good as the prior one. No 30-degree days, but generally speaking, it was good drying. 20 degrees C daytime and 40% humidity. Nighttime lows of maybe 10 degrees and 85% humidity. Again, we used the same natural gas fueled hydronic supplemental heater. And this system had a premium air delivery system. So it had an 8-foot by 24-inch horizontal air tube. And we teed into that with an 8-foot by 15-inch vertical rocket. And then we also added sidewall vents. So this was basically had cross flow system. So we had a really efficient method of getting a lot of air right into the core of the bin. And the sidewall vents also provide the ability to flow horizontally. Here's the results. Again, the temperature graph. With this one, we didn't start the heater for the first 2 days, and you can see the plenum, the bright red plenum temp was slightly higher, but just a little over the ambient. And then here at about the 40-hour mark, we turned our supplemental heat. You can see how the plenum temp jumped up, and we're adding about 10 to 15 degrees Celsius from that point on to our airflow. Now, the thing that really is interesting with this slide is that initially we were only removing about 1 gallon per hour, and the instant that we started our supplemental heat with this premium air delivery system, it jumped up to 6, probably averaging about 6 gallons per hour. So that is about twice what it was in the prior system with just the standard air delivery system. So you can see how enhancing with the 5-horse fan and a premium air delivery system, you can get more air out of the bin, or more water, sorry, out of the bin, and it just improves your overall speed of drying. Here's the real-time moisture content. Again, you can see the first 2 days didn't do a whole lot with just natural drying. And then as soon as we turned our heater on, we went from about 17.5 down to about 12.5. So we took 5 points of moisture out of that over 250 hours, which is roughly 10 days. But again, you can see that the first 2 days we really didn't do anything. So really that was about 8 days of drying to get those 5 points out. Here's just a plot showing your ambient humidities and your drying, and it's an interesting thing to note here is how whenever our ambient humidity spikes down, our grain drying rate spikes up, and that gives you a real good feel to how your ambient humidity is important, and this coincidentally is happening during the heat of the day. So obviously you want to be running this during the heat of the day, and as soon as you have supplemental heat, we definitely recommend running it 24/7. Here's our costs. Again, the real-time cumulative costs. Here we're just running the fan, so it's a flatter curve. We're incurring costs slower. As soon as we turn the heat on, we're adding our fuel costs for the heater. And then this was a cooling episode where we just cooled the grain for about 12 hours. Our total cost was $350 for these 4,100 bushels, which works out to 1.7 cents per point. So that is so the premium air delivery system not only lets you dry more grain, but it also reduces your costs. So it really enhances the overall system and the efficiency of using your bins more efficiently.